In this video, I'm going to show you how to set up the Frigate network video recorder on a Raspberry Pi 5 with an IP camera using Geekworm's X1004 dual NVMe SSD shield. It has two M.2 NVMe slots. One slot will have the Google Coral Edge TPU, which will be used by Frigate for object detection, and in the other, an NVMe SSD used as a boot drive and to run Frigate. We'll also integrate Frigate with Home Assistant. Could this be your long-term NVR solution? Let's find out. Frigate provides an open-source NVR solution that processes camera feeds locally using real-time artificial intelligence for detecting an object of interest such as a person, car, cat, and more. It is strongly recommended to offload object detection from a CPU to a Google Coral Edge Tensor Processing Unit or TPU, which is used to accelerate inferencing for deep learning applications. The Google Coral is able to outperform powerful PCs in processing the camera feed with minimal overhead. Frigate also has features such as zones and masks. With zones, you can determine the exact moment your object of interest moves into the area you specified, while masks are used to prevent unwanted types of motion from triggering detection, like trees blowing in the wind, camera stamps, and more. We'll look at masks later on in the video. You can also integrate Frigate with Home Assistant and other automation platforms. If you're only interested in the Home Assistant integration, you can skip to this timestamp. The Google Coral TPU comes in different forms. We'll be using the PCIe form factor in this video. There are other detectors supported by Frigate, and you can read more about them on the Frigate recommended hardware page. This link will be included in the video description. The recommendation to use a Google Coral comes from this line. Setting up Frigate on a Raspberry Pi has already been done before. For instance, Data Slayer used a Raspberry Pi 5 with a Pine Boards hat and a PCIe Google Coral Edge TPU, and Fixed SE used a Raspberry Pi 4 with the USB Google Coral Edge TPU. But in my case, I'm using Geekworm's X1004 dual NVMe shield. And like I said in the preview, this will enable me to insert the Coral in one slot and an NVMe SSD drive in the other, which I can boot from, run Frigate on, and save its snapshots and recordings. An SSD has faster read and write speeds compared to a microSD card, which will improve performance in saving snapshots, videos, and playing them back. I did a simple bench test comparing read and write speeds here. My main motivation for working on this project was because of a break-in we had some weeks ago, and disappointingly, the off-the-shelf security system we have did not detect any motion or record any events. Thankfully, nothing happened, but I had to find an alternative. I also wanted a system that did not require an internet connection after the initial setup. So if you have Geekworm's dual NVMe SSD shield, I wanted to find out how to run Frigate on it to use as your NVR solution. This video is for you. But before we start, I'm going to assume that you have some experience with Docker, MQTT, and Linux commands, and that you have set up Home Assistant and the Home Assistant Community Store for those that are interested in the Home Assistant Frigate integration. Regardless, there are links in the video description to get you started with these concepts. And if you prefer to read, you can follow the project README, which is basically the written form of this video with some additional information. Finally, you can skip through the video with the timestamps included. With all that out of the way, let's look at what we need. We need a Raspberry Pi 5. I'm using the 8 gig version. I don't have the 2 gig or 4 gig versions for a comparison, but I assume that it will work as well. Next we have the power supply for the Pi 5. This is the Google Coral Edge TPU, which I will set up later on. Here's a Geekworm X1004 dual NVMe SSD shield. Like I mentioned earlier, this has two NVMe SSD slots that can take up to 4 TB each, bringing the total storage to 8 TB. so it can serve as a very good network attached storage or NAS or a home media solution. It should be noted that it only supports PCIe Gen 2 speeds, not Gen 3, because of the AS Media PCIe switch the Shield uses. But for our purposes, we're going to install the Edge TP in one slot and an NVMe SSD drive in the other. Another thing to note is that the Shield is only compatible with M.2 NVMe SSDs. You can read more about the Shield from Geekworm's documentation, which I include in the video description. There is also the Raspberry Pi 5 Active Cooler. I'm using this one from Argon 40. The Active Cooler helps to bring down the TPU temperature. You can check out the temperature test I ran here, which compares the results of passive versus active cooling of the Coral. Then we have the IP camera. I'm using this one from Dahua. Hope I'm pronouncing that well. It meets the requirements of supporting H.264 encoding and the real-time streaming protocol, or RTSP. I'll talk more about the specs in the IP camera video chapter. Next is the microSD card. Raspberry Pi recommends a minimum of 16GB for the Raspberry Pi OS Lite. Pi will initially boot from the microSD card so that we can upgrade the EEPROM firmware version to the one that supports booting from SSDs. I'll get into all this in the next video chapter. Then there is the microSD card reader, used to flash the Raspberry Pi OS Lite image on the microSD card. This is the NVMe SSD drive, which we will boot from, run Frigate on, and also save its recordings and snapshots. Geekworm maintains an updated list of NVMe drives that are not compatible with the NVMe Shield. However, over time, more drives are made compatible through EEPROM updates and adjusting boot config settings, so you can periodically check this page for any drive changes. This is the NVMe SSD enclosure, which will be used to flash Raspberry Pi OS Lite on the NVMe drive. Other things you need are a router and a Power over Ethernet or PoE switch, which connects to the router's network. It will power the IP camera and send data to it, and also send data to the Pi 5 if it's connected to the switch. And for those of you that are interested in the Home Assistant integration, you will also need a computer to run Home Assistant on. This diagram shows how the network devices will be connected. Now we know what we need. Let's start setting things up, starting with flashing a microSD card with Raspberry Pi OS Lite. I chose a Raspberry Pi OS Lite because the Pi 5 will be running headlessly, so the desktop variant of Pi OS is not needed. On a side note, I did consider Ubuntu Server 2404, but I encountered some issues setting up the Coral. The Raspberry Pi imager will be used to flash Pi OS Lite on the microSD card. I'm using Ubuntu so I can click on this button to download the imager. There are also options for Windows, macOS, and Raspberry Pi OS. At this point, plug in the microSD card into the PC. I already have Raspberry Pi imager installed, so I'll just open it up. Then choose Raspberry Pi 5 as a device. For the operating system, go down and click on Raspberry Pi OS Other. Then Raspberry Pi OS Lite. I already have this cached on my PC, so this should speed things up. Choose the microSD card you just plugged in as storage. Then click on Next. Here we're being asked if you want to customize the OS. Yes, we do. So choose Edit Settings. Under the General Settings tab, choose a host name, a username, and password. The host name is a unique identifier for the Pi 5 on the network. Navigate to the Services tab. Check Enable SSH, then choose Use Password Authentication. Enabling SSH provides secure access to a terminal session on the Raspberry Pi 5 from any device on the same local network as the Pi. Commands can be sent to the Pi 5 over the network to run programs, change settings, and install packages. Now we can save these settings and click on Yes. And choose Yes again to overwrite any data on the microSD card. You need to put in your admin password before the imager starts writing the OS image to the microSD card. I'll fast forward this. We can eject the microSD card now. Let's look at the setup process of booting from the NVMe SSD. Insert the newly flashed microSD card into the Raspberry Pi 5. Plug an Ethernet cable from the PoE switch or directly from the router, then connect the Pi's power supply to power it on. Give the Raspberry Pi roughly 30 seconds to boot up before proceeding to the next step. You can also connect a monitor at this point to confirm when the boot up process is done. Back on the computer, open up a terminal window. We'll connect to the Pi using SSH by running this command, which is ssh username you chose at hostname you chose.local. When connected to the Pi for the first time, you'll be prompted to confirm the authenticity of the host. Type yes and enter the password you chose to log in. In order to boot from the NVMe, we first have to update the bootloader on the Pi 5 to a version dated at least 17 May 2024. The bootloader contains code which starts up the various hardware components and loads the OS. It's stored on the Pi 5's EEPROM. Let's clear the terminal screen. The current bootloader version can be checked by running this command. This version is dated 12 November 2024, so we can boot from an NVMe SSD. But let's go through the steps to update the bootloader version. Run the command sudo raspi config. Scroll down to Advanced Options and press Enter. Then select A5 bootloader version. Click on E1 Latest and choose Yes. Then click on OK, Finish, and finally reboot the Pi for the bootloader update to be effective. I've SSH'd again into the Pi. The next thing we need to do is to enable the PCIe connector on the Pi 5 because it's disabled by default. To enable the PCIe connector, we're going to edit the bootconfig.txt file in the nano editor with this command. All the commands used in the video can be found in the project readme. Then add the following lines at the end of the file. Save these changes and close the editor by typing Ctrl X, choose Yes, then reboot the Pi. Let's SSH in again. Now we need to set the boot order for the Raspberry Pi 5 to boot from an NVMe SSD first, before trying out other options. Let's clear the screen and open up Raspberry Pi config. Scroll down again to Advanced Options. Choose A4 boot order. Click on B2 NVMe/USB boot. Then click on OK. Finish and choose Yes to reboot. With the PCIe connector enabled and the Pi 5 set to boot from an NVMe first, the only thing left to do is to boot the Raspberry Pi 5 from the NVMe SSD. We'll flash the Pi OS Lite on the NVMe SSD using the NVMe enclosure, following the same steps employed in flashing the microSD card. To keep the video short, I won't show this process again. So let's shut down the Pi 5, unplug the microSD card and power cable, then assemble the dual NVMe SSD shield. Plug in the Ethernet cable and power on the Pi 5. Next, SSH into the Pi with the chosen username and hostname. I chose Frigate Pi for both. These are the results of the speed test comparing the microSD card and the NVMe SSD. The write speeds were tested by writing 1 GB of data in 10 blocks of 100 MB each, while the read speeds were tested by reading the generated data in 10 blocks of 100 MB. Let's set up the Google Coral Edge TPU. The Google Coral Edge TPU needs to be configured to work on the dual NVMe SSD shield and the Pi 5. This includes installing the required drivers and packages, restoring the Edge TPU runtime, and adding some lines to the bootconfig.txt file to get the Coral to run. I wrote this GitHub gist bash script based on this guide from Pine Boards to configure the Coral. Let's look at the script in the raw format. This line added to the bootconfig.txt file enables the Pi to detect the Coral driver. The solution was offered by JDB in this Raspberry Pi forum post. Going back to the raw file, we'll copy the URL which we'll use to run the bash script. This command executes the script on the Raspberry Pi to configure the Coral. My internet connection is a bit slow, so I'm going to fast forward to the end. The script reboots the Raspberry Pi to effect all the changes. Let's SSH in again. And clear the screen. To verify that the Coral driver is loaded, run the following command. This lists out information about all PCIe buses and devices on the Pi 5. We can see the details about the Coral here. Next, let's check if the Coral is connected and detected by the Pi with this command. And this is the expected output. You can also confirm that the Coral TPU works well by installing the Pi Coral library and running image classification tests with these guys from Pine Boards and Google. But we'll proceed to setting up the IP camera for Frigates, with the assumption that the device is working properly. To obtain the most compatibility with all the Frigates and Home Assistant features, the IP cameras used should output H.264 video and AAC audio. Additionally, it will be beneficial that the chosen cameras support multiple substreams to allow different resolutions to be used for the detection, streaming, and recording without re-encoding. Delaware cameras are recommended because they are more readily available compared to other brands and meet the Frigate requirements. This image shows the video pipeline that Frigate uses to process the camera feed. The pipeline starts by obtaining the camera feeds, and if the camera has a substream, this will usually be decoded to produce full-frame images. During this process, the resolution may be downscaled and image sampling frequency set. These frames would then be compared over time to detect movement errors or motion boxes. Then these boxes are combined into motion regions and are analyzed by a machine learning model to detect known objects. Finally, video clips and events are saved based on the snapshots and recording configuration. There's more information about this in the Frigate documentation. This YouTube video by Ecological Time provides a walkthrough on how to set up your Dahua camera. Take note of your camera's IP address, username and password. These will be used in the next chapter. Here are my Dahua camera configurations. I use the example camera configuration provided in the Frigate documentation as a guide. My camera's substream resolution doesn't go up to 1280 by 720. Mine was configured at 640 by 480. But it still performs well because Frigate doesn't pass the entire camera frame to object detection. Instead, it crops an area of motion from the full frame and looks in that portion of the frame. If the area being inspected is larger than 320 by 320, the dimension of the model used by Frigate, Frigate will resize it before running object detection. You can read more about choosing a detect resolution on this page, which is also linked in the video description. Now, let's install Frigate. From the documentation, Frigate is defined as a Docker container that can run on any Docker host, including as a Home Assistant OS add-on. Note that the Home Assistant add-on is not the same as the integration. the integration is required to integrate Frigate into Home Assistant. I'll get into add-ons and integration later on. So we need Docker to install Frigate. Like I mentioned in the intro, I'm assuming that you have some knowledge of Docker. However, this YouTube Docker crash course by TechWar with Nana and the official Docker Getting Started guide are good places to start out with Docker. I wrote another GitHub gist bash script to install Docker based on the Debian install steps provided by the official Docker guide. Looking at the raw file, copy the URL and go back to the terminal. Run this command to execute the bash script. Again, this might take a while, so I'm going to fast forward to the end. The script also reboots your Raspberry Pi 5 after it's done installing Docker. So let's SSH in. We can test out the Docker installation by running this command, which pulls the hello world Docker image, then runs a container. This will output the following image, confirming that our installation is working properly. The next thing we'll need to do is to create the necessary files and directories for the Frigate's configuration and storage. I use this Pineboard's blog post as a guide. Create the config and storage directories with these commands. Remember to replace Frigate Pi with the username you chose when flashing the OS on the NVMe drive. We'll create the Frigate config.yaml file in the config directory. I'll paste in this config, which is sufficient to start up Frigate. I'll explain the different sections shortly. We'll use a Docker Compose file to configure the Frigate container installation. Let's navigate to the Frigate directory, then create the Docker Compose.yaml file. I'm going to paste in these lines in the config file. You can find the config files in the project GitHub repository. Let's make a few changes. Under volumes, I'm going to replace the Pi username with Frigate Pi. And under environment, I'm going to change the placeholder Frigate RTSP user and password to the username and password of the IP camera. Then save and close the file. Finally, run this command, which will pull the Frigate Docker image and deploy the container with the configuration set. The -d flag is used to run the container in detach mode or in the background, meaning it doesn't flood the terminal with container log data. Pulling the image took longer than expected, so I'm just going to skip to the end. If everything went well, you should be able to access the Frigate web user interface in the browser by either using a Raspberry Pi hostname or with its IP address with port 5000. Let's use a hostname. That's me. You can edit the config.yaml file using the configuration editor by clicking on the gear button in the bottom left corner, then on configuration editor. Let's talk about the different sections of the config file. MQTT is disabled for now, but it is required for the Home Assistant integration, which we will look at soon. There's some links on getting started with MQTT in the video description. These lines specify the detector to be used. Ours is a single PCIe Google Coral Edge TPU. Next is the camera config. I chose testcam as the name for the camera. The camera input RTSP path uses one of the URL options for remote access or RTSP stream with Dahua cameras. These options are highlighted here. Other camera brands might have different URL options. Remember that Frigate RTSP user and password are Docker environment variables for the IP camera's username and password. The IP camera address is 192.168.8.201 and 554 is the default RTSP port. For my Dahua camera, setting the subtype to 0 uses the main stream, while a value of 1 uses the substream. It is recommended to use the substream for object detection. I'm using the mainstream here for test purposes. Your option to copy the configuration, save config changes and restart the Frigate container, or simply to save them in the top right corner of the Frigate UI. We can also check out system metrics. Click on the gear button again and on system metrics up top. Here we can view information about the Google Coral detector inference speed, temperature and more. Tabs for storage and cameras include information about the camera storage and detections respectively. Under Configuration, click on Settings. Here we have tabs for General Settings, Camera Settings, Mask/Zones. We'll look at how to create masks later on. Motion Tuner, Debug. Here you can toggle on bounding boxes, timestamps, motion boxes and more. There's also a list of objects detected by Frigate. And finally, users. You can go through some of these tabs using the Frigate documentation as a guide. With Frigate installed and running, let's set up Home Assistant for the integration. Home Assistant is an open source home automation platform that prioritizes local control and privacy. Users can integrate over 1,000 different devices and services, perform automations with these devices, and visualize smart home information using dashboards in Home Assistant. Your smart home system can be extended using add-ons and can be controlled with your voice using the Assist voice assistant. There are more Home Assistant features which can be explored on your homepage. There are 4 different installation methods for Home Assistant, depending on the features required. We need to either install Home Assistant Operating System or Home Assistant Supervised, as these are the only methods that allow use of add-ons, which is a requirement for integrating Home Assistant with Frigate. I assume that you already have Home Assistant OS installed. If not, check out the links in the description. I have Home Assistant OS installed on the Minus Forum mini PC. Let's briefly go over the Home Assistant concepts of add-ons and integrations. From the Home Assistant concepts and terminology page, add-ons are defined as third-party applications that provide additional functionality in Home Assistant. Some examples of add-ons are an MQTT broker or a file editor. All integrations are pieces of software that allow Home Assistant to connect to other software and platforms. Add-ons run directly alongside Home Assistant, whereas integrations connect Home Assistant to other apps. For instance, Frigate integration connects Home Assistant to Frigate. We'll use the official Mosquitto broker add-on for our Home Assistant integration. This is my test Home Assistant instance. Again, from the Frigate documentation, an MQTT broker is optional with Frigate, but is required for the Home Assistant integration. If using Home Assistant, Frigate and Home Assistant must be connected to the same MQTT broker. But before setting up the MQTT broker, we need to create a new person in Home Assistant with login credentials that will be used when we're configuring the broker. Go to Settings at the bottom left of the page, scroll down to People, then click on Add Person at the bottom right corner. Pick a name for the person. We'll use MQTT broker. Then toggle on the Allow Login button. The username is set to the name you chose by default. Next, input a password and confirm it. Toggle the Local Access Only button. Click on Create, then on Create again. Let's go to Settings. Then click on Add-ons. Search the add-on store for Mosquitto. Then click on Install. This might take a while, so I'm going to skip to the end. Start the add-on once it has been installed. Let's set up the MQTT integration. Again, let's go back to Settings. Then on Devices and Services. Click on Add Integration at the bottom right and search for MQTT. Here, pick MQTT. We're asked to choose how we want to connect to the broker. Choose Use the official Mosquitto MQTT broker add-on. Now, this is where the Mosquitto add-on is started. We successfully created a configuration for Mosquitto. Click on the MQTT integration, then on Configure. Select Reconfigure MQTT. This will open up the broker options. Here, input the username and password you chose for the new person you previously created. Then click on Next. There are more options here, but we'll stick to the defaults. Scroll down. And click on Submit to save the configuration. With MQTT configured, we're going to make some changes to the Frigate config.yaml file before setting up the Frigate integration. Back in the config editor, I'm going to paste in this configuration. Here, we're enabling MQTT by providing the host IP address of the computer running Home Assistant and the login credentials for the MQTT broker. Go to RTC is a camera streaming application which supports a lot of streaming formats like RTSP, RTMP, WebRTC, and more. Adding Go to RTC is optional, but if you wish to live stream the camera feed in Home Assistant, Go to RTC would need to be configured. The snippet shows how Go to RTC is configured using RTSP. You can find guides on how to use different streaming formats in the documentation. Frigate offers flexibility on how video is recorded. One can choose to record all video from the camera feed, only save video when motion is detected, or only record video when an event is ongoing. You can check out the different configuration permutations for recording in the documentation. The snippet only saves video when motion is detected and retains the footage for 30 days. And the record roll is added to the camera stream with a higher resolution. If you plan to create automations in Home Assistant, using motion events detected by Frigate, the detect configuration has to be enabled. The sample automation could be if camera A detects motion from 10 p.m., turn on outdoor light A for 10 seconds. The detect functionality is optional and can be toggled on and off for each camera in Home Assistant after integrating Frigate. Finally, we have snapshots. These are pictures of an event in JPEG format. Enabling snapshot is also optional, and like the detect functionality, it can be toggled on and off in the Frigate Home Assistant integration. You can find this config file in the GitHub repository. There's a lot more that can be configured in Frigate. This full reference configuration guides you through the different config options. Next, we're going to integrate Frigate in Home Assistant. Not all integrations are supported by the Home Assistant development team. This is where the Home Assistant Community Store comes in. The Home Assistant Community Store, or HACS, is a custom integration that provides a UI to manage custom elements in Home Assistant. They define the custom element as a Home Assistant element such as an integration, dashboard, theme, or template that was created by someone from the community and published for others to use at their own risk. We're going to use a HACS integration for Frigate. HACS can be installed by following the documentation. I also included a YouTube video in the description to guide you through the installation process. After installing HACS, open it up on Home Assistant and search for Frigate. Click on the first option, but we will install the Frigate card shortly. Then click on Download and download the version shown. Next, we'll be prompted to restart Home Assistant, but let's install the Frigate card, which we will use later on to create a dashboard to live view cameras, browse through clips and snapshots, and more from Frigate. Again, click on download and download the version shown. Let's reload the browser to use the updated resources. Okay, now we can reboot Home Assistant. After Home Assistant has rebooted, go to Devices and Services. Click on Add Integration and search for Frigate. Here you need to input the URL to access Frigate. Either input the IP address or hostname of the Raspberry Pi 5 with port 5000 and click on Submit. I prefer to use the hostname. Click on Submit. We successfully configured the integration and it found the test camera and Frigate as devices. So let's look at them. Click on Devices under the Frigate integration. Then on Frigate. I'm going to enable these diagnostic entities. An entity represents a sensor, actor, or function in Home Assistant. Apex 0 temperature is a temperature entity, which we'll use to plot some temperature graphs later on. Click on the gear button, then enable. OK, then click update. I'll speed through enabling the others. Click on the test cam device. Under sensors, there's information about the camera state, which is recording at the moment, motion detected, person count, occupancy, and more. And down here under configuration, we can see the toggle buttons for the config options we set in the config.yaml file. Now we're going to utilize the Frigate card we downloaded earlier to create a new dashboard. To create a dashboard, go to Settings, then Dashboards. At the bottom right, click on Add Dashboard, then choose New Dashboard from scratch. Choose a title for the dashboard and search for an icon for it. Then click on Create. Open a newly created dashboard and click on the Edit button in the top right corner. Click on Create section, then on Add Card. Here search for Frigate, then select Custom Frigate Card. Click on Cameras to add to the card. We only have test cam, then click on Save. Let's make the section a bit wider by clicking on the Edit button and drag the width to the right, then save. You can also make the card wider. Click on these three dots, then on Edit. Under Layout, toggle on the Full Width Card button, then save. Click on Done to save the dashboard. Let's give it a few seconds to connect. This is the live view, but I can't see the full image. I'm just going to make a few more layout changes. That looks better. The live feed is shown by default. Clicking on the Frigate logo brings up different menu options, which are Frigate menu, live view, clips gallery, snapshots gallery, timeline view, which shows what events have occurred over a specified time period. Let's click on this event, which is a recording. Notice the difference video quality between a recording and a live stream. That is mainstream versus substream on your camera. Back to the live view. The Frigate data can also be viewed in the media browser in Home Assistant. Click on Media on the dashboard panel on the left, then on Frigate. We have clips, recordings, and Snapshots. Now let's learn how we can create motion masks in Frigate. We'll demonstrate how to set up a motion mask on the camera timestamp to prevent it from triggering object detection in Frigate. Back in the Frigate Web UI, go to System Settings. Click on the Debug tab and toggle on motion boxes. This shows red boxes around areas where motion is detected. In the top right corner, you can see a red box around the second digits of the timestamp. To create a motion mask, click on the Mask/Zones tab, then on Motion Masks, and start creating the polygon around the timestamp. I encountered some difficulty closing the polygon around the timestamp. You might have to try a few times to get this to work well, so I cut those parts out of the video. But once you've been able to close the polygon, click on Save. You get a confirmation message that the motion mask has been saved, and we're prompted to restart Frigate to apply the changes. But before we do that, let's open the config editor. Here you can see that the coordinates of the motion mask have been added to the config file. Now let's save the configuration and restart the Frigate container to effect the changes. Going back to the Debug tab, we can see that there aren't any red motion boxes around the timestamp, so the masking worked. You can use this feature for a section of your camera feed you don't want triggering detection. Before ending the video, let's see how we can plot graphs of the Google Coral TPU temperature in Home Assistant. Out of curiosity, I wanted to compare how hot the Google Coral Edge TPU gets when Frigate is running. I considered three cases: the Pi 5 without the active cooler, the Pi 5 with an active cooler, and the Pi 5 with an active cooler in a Geekworm metal case. The TPU temperature data is accessed from the Apex 0 temperature entity we enabled earlier. We'll be using a Plotly graph card from Hacks to plot our temperature graphs. Open up Hacks and search for Plotly. Click on Download and download the version shown. Then reload your browser. Let's create a new dashboard for our graphs. Under the card section, search for Plotly and add a custom Plotly graph card. Give the graph a title. For the hours to show, I use 0.25, which means that it will show data over a 15-minute rolling window. Under Entities, choose Frigate Apex 0 temperature. We can make a few layout adjustments, then save the configuration. Let's also make the section full width. And click on Done. These are the current temperature readings, with the temperature on the y-axis in degrees Celsius and time on the x-axis in minutes. To keep the test conditions fairly constant, I had no external fan or air conditioning in the room the Pi 5 was in. Frigate was working on a live feed of me in the room, and I shut down the Pi before each test and allowed it to cool down. And these are the results. As you probably guessed, the core temperature without the active cooler climbed steadily to over 60 degrees in this test, and it was hot to touch. The best configuration is the Pi 5 with the active cooler without the case. Here the active cooler fan levels the core temperature around 55 degrees. The metal case setup doesn't dissipate heat as fast. The temperature flattens around 60 degrees Celsius. Having an external fan or air conditioning in the room should bring down the core TPU temperature, regardless of the setup. So you successfully configured Frigate to run on your Raspberry Pi 5 using Geekworm's X1004 dual NVMe SSD shield with the PCIe Google Coral Edge TPU. We also integrated Frigate with Home Assistant. Can this be your long-term NVR solution? Because I configured the setup as my long-term NVR solution, I got Geekworm's X1202 UPS shield and their X1202 C1 metal case. The X1202 provides backup power using 4 18650 batteries, but this isn't necessary. You can just get a case that fits the dual NVMe SSD shield. Frigate performs well out of the box. I'm currently using it with 3 cameras and so far it's much better than my previous system, which didn't pick up any movement at night, but Frigate does. However, you can look through the documentation on how to tune Frigate for better performance. Remember that the NVMe SSD shield slots can take up to 4 TB of storage, so you can upgrade yours or move the Frigate storage to a NAS via file sharing protocols like Server Message Block (SMB) or Network File System (NFS). This is the list of objects that can be detected by Frigate. You have to specify them in the config file. Check the full config reference on how to do that. Another way to improve accuracy on Frigate is by using Frigate Plus. With it you get models fine-tuned to your cameras and is also a great way to support the Frigate developers. Unfortunately, I wasn't able to set up notifications for Frigate using Home Assistant. This blueprint at the time of recording didn't work for me. I'm still fairly new to Frigate and Home Assistant, so if I made a mistake or you have some feedback, please let me know. All the relevant links are in the description. Thanks for watching.